All right, let's do problem number 19 on page 823, chapter 26. Here's the problem in the book. It says, well, if I can fit it in there. It says two capacitors, when connected in parallel, give an equivalent capacitance of 9 picofarads and give an equivalent capacitance of 2 picofarads when connected in series. What is the capacitance of each capacitor? And so we have this. Let me I set it up right here. Zoom out, get myself a little more round. Okay, well, let's solve it. So well, these here are in parallel, and so we know that capacitors in parallel, you just add the capacitance to get the equivalent capacitance. So C1 plus C2 equals 9 picofarads. And but we have two unknowns here, so we need another equation. Well, we have another equation that we can get from them being in series, and this is 1 over C1 plus 1 over C2 equals 1 over 2 picofarads. Okay, so now it's just a matter of solving these simultaneously, and I guess I'll solve for C1, and so so we have I'll just do it. So C1 equals 9 picofarads minus C2. So I'm going to substitute that in here, and it doesn't matter which one you do this for. So this is going to be 1 over 9 minus C2. And sometimes I do drop units just to make the algebra a little bit easier. Plus 1 over C2 equals 1/2. And now I need a common denominator. I think there was an easier way of doing this. I saw some of you doing it a little tricky, where you actually expanded it out. So I don't know. I'll go with this, and then if I screw it up, then I'll take a look at one of your papers. So I need to have a common denominator here. So this is going to be C2 plus 9 minus C2 over C2 times 9 minus C2. Is that right? This, you're going to add them together. And here I just multiplied top and bottom by C2, and here 9 minus C2. So I think that's right. You agree with that? No? Yeah, I think this is right. And this is equal to 1/2. And so, how do I solve for C2 here? Should have worked this out in advance. I always have trouble with these. Let's put this over on the other side. So we have C2 plus 9 minus C2 is equal to C2 9 minus C2 over 2. Hey, if you see a mistake being made, call out, okay? Yes? Oh, okay, okay. Because I'm a little, so, oh, here we have a C2 minus C2, so that's going to go away. So we're going to have a 9 equals C2 times 9 minus C2 squared over 2. So I'll multiply both sides by 2, so I'll have 18 equals C2 times 9 minus C2 squared. I think this makes sense. Now this looks like a quadratic, so I'm going to put this on the other side, so it's just going to be C2 squared minus 9 times C2 plus 18 equals 0. Is that right? Is that right? Okay. So now I can use the quadratic formula. C2 equals, what is the quadratic formula? Isn't it b plus or minus the square root of, is it b? Negative b. So negative 9, negative b plus or minus the square root of b squared minus 4, a is 1, and c is 18. All over 2a, so that's just going to be 2. Is that right? Did I do that right? Okay, so this is going to be well, this is going to be 9 plus or minus, well, this, what's in the radical there? I'm going to have 81 minus 4 times 18, right? Equals 9. I'm going to take the square root of 9. Is that right? Times 10 to the z. And then, so this is 3. Oh, that's nice. So it's 9 plus or minus 3 divided by 2. So let's go 9 plus 3 is 12. 12 divided by 2 is 6. And the units were picofarads. But if it's minus 3, it's 9 minus 3, that's 6. 6 divided by 2 is 3. Which means that C1 equals 3 picofarads, C2 equals 6 picofarads, or you could switch them. I mean, it was arbitrary, right? Which one was C1 and which one was C2. So this is C1 equals 6 picofarads, and C2 equals 3 picofarads. Either way you did it, didn't really matter. So I think that is done. Some of you did it without using the quadratic formula. I think you had C1 and C2, and then you expanded it out. You factored it, and you got the right answer from that. So that was good. Hey, a couple of you, when you used the guess and check. And if you guessed and checked, and you got 3 and 6, and you showed, hey, 3 and 6 work. Well, I gave you 5 points, but I can't really give you full credit for that. You gotta give me, you gotta derive it more rigorously than say, hey, this works. Still. Okay, any questions on this? I was a little worried I screwed it up, but it worked out. Okay. That is all.